everyone, welcome to the course Structure Analysis. Myself, Dr.S.Pachaiappan, Assistant Professor, Department of Civil Engineering, Aditya University. So today we are at lecture 3. In first lecture, already we have discussed about what is meant by structure analysis and then its importance and application of the subject. And then in the lecture 2, we have discussed about different types of beams and then support condition. So among the different types of beams, one of the type of beam is a propped cantilever. In today's lecture, we are going to see how to calculate the prop reaction. Okay. So the lecture is titled as Analysis of Propped Cantilever Beam 1. So we are going to see the procedure and then also some example problems. So this is the procedure to calculate the prop reaction. So earlier we are discussed about the difference between statically determinate structure and statically indeterminate structure. So statically a determinate structure means any problem can be solved by using only 3 simultaneous equations, equilibrium equations, that is summation of all the horizontal forces equal to 0, summation of all the vertical forces equal to 0 and summation of all the moments at any point is equal to 0. So if any problem cannot be solved by using the 3 equilibrium equations alone, that is called as a statically indeterminate structure. Okay. So I already told you the statically determinate structure is already discussed in the strength of materials 1 and then structure analysis 1. So in this course, we are going to see completely a statically indeterminate structures. That means whatever the problems we are going to see in this lecture, that cannot be solved by using the equilibrium equations alone. Okay. So it's a very simple procedure, only it is having a 3 steps you can able to see in the screen. So step 1, I am going to remove the extra support, that is a prop support is nothing but the extra support given in the problem. I am going to remove the prop support and then considering that is a normal cantilever beam. So cantilever beam means what? The one end is fixed and other end is free. So if it is a propped cantilever, at the free end also I am going to have some support. So that free end support I am going to remove. The free end support I am going to remove. So this is my step 1. What is the step 2? Still we are in step 1 only. After removing this prop reaction, the prop support, I am going to consider whatever the load on the structure, load on the beam. Either it may be the UDL or point load, whatever it is. I am going to remove the prop support, that extra support, and considering the whatever the load acting on the structure. And then I am going to calculate the downward deflection. So it's just a procedure. When I'm explaining with the example, it's very easy to and very clear to understand. Okay, just listen to the procedure. So I'm going to remove the prop reaction, considering the whatever the downward load acting on that structure, and then calculating the downward deflection. What is the second step? I'm going to remove the load on the beam and then considering only the prop support. So it's vice versa. First thing I am considering the removal of the prop support. In second case, I am considering the removal of the load and then calculating the upward deflection. Once again, I will repeat the step 2 is we are going to remove the load acting on the beam, that is UDL or point load, and I am going to only consider what? The prop reaction. Okay. So I am calculating the upward deflection. And the step 3 is I am going to equate the downward deflection due to the load and upward deflection due to the prop reaction, so that easily I can able to calculate the prop reaction. Okay, let me take some example. First of all, we need to tell why the propped cantilever beam is statically indeterminate structure. I will explain that and then I will get into the procedure to calculate the prop reaction. Okay. So whatever I am drawing here is a propped cantilever beam. One end is fixed and other end is we are having the roller support. Okay. Let's consider this beam is having the uniformly distributed load UDL, the intensity is W per meter, and we give some length, that length is L. Okay. Let's give some names also. This is support A and this is support B. Now I am going to prove why the propped cantilever beam. This is the propped cantilever beam. So this is a propped cantilever beam. I am going to prove why the cantilever beam is statically indeterminate structure. Okay. So let's calculate that. If you look at into this problem, let's take a different color. At support A, I am going to have the reaction. Let's say this is vertical reaction. I am naming it as a VA. Similarly, and support B, I am going to have the vertical reaction. Let's say it's VB. So two vertical reactions. And then at support A, I am going to have the horizontal reaction HA. And then at support A, I am going to have the moment which is MA. So there is no horizontal reaction is possible at B because it's a roller support. It's not going to restrain the forces, it simply move. Okay. Let's mark how many forces are I marked here. Okay. Let's mark 1, 2, 3 and 4. So total number of unknown forces are 4. So what is mean by the static indeterminacy? Already we discussed. The degree of static indeterminacy is nothing but number of unknown force minus number of equilibrium equations. Number of unknown force minus number of available equilibrium equations. So we know what is the equilibrium equation. Summation of all the horizontal force 0, summation of all the vertical force 0, summation of all the moment equal to 0. So total number of available equilibrium equations are 3, total number of unknown forces are 4. So unknown forces are 4 minus available equilibrium equations are 3. So we are getting the value 1. That means what? This 1 represents the property cantilever is statically a indeterminate structure. That means these 3 equations alone, we cannot, using these 3 equation alone, we cannot able to solve this particular problem. We need one more additional equation to solve this problem. That's why this is statically indeterminate structure. If suppose instead of 1 here I am getting 0, then that is a statically determinate structure. Then one may ask, sir, always we are going to have the statically indeterminate structure means we are going to get 1. No, this is a very simple problem. That's why we are getting the degree of static indeterminacy is 1, but the degree of static indeterminacy may be hundreds also depending upon the problem. So those problems will be taken care of by the computer programmings. For example, already developed software, StatPro, ETABS, all those things. If when we are having the 100 degree of static indeterminacy, we are not going to solve that problem manual calculation first of all. So the static indeterminacy may be up to 10 to 15 we can able to solve by manual calculation, but that itself is a tedious process. So now you understood why this cantilever beam, property cantilever beam is statically indeterminate structure. Now I am going to explain. In the first slide we have seen the procedure to calculate the prop reaction that we are going to discuss. So let's take the cantilever beam, and then at the end I am having the another support which is the prop. Let's consider this beam is having the uniformly distributed load UDL and the intensity is W per meter, and the span of the beam is L. The span of the beam is L. Give some names also. This is A and this is support B. Let's go by step procedure. What is the step 1? Hope you remember. The step 1 is I am going to remove the prop support. Okay. So, let's remove the prop support. I am going to remove the prop support and consider only the downward load, which is UDL here. Okay, let's do it first, and then similarly I am going to calculate the downward deflection. The notation is del downward. Okay. So, let's take a beam once again, mark the UDL which is W per meter, mark the span, mark the supports A and B. Now, I am not specified the prop support because I removed it as per my procedure. Remove the support, remove the not general support, remove the prop support. Okay, because here two supports are there. So, no confusion, we are removing the prop support. Now, I am going to calculate the downward deflection. Let's take a different color. Because of this load acting in a downward direction, because of the gravity, this beam is going to deflect in a downward direction. Okay. So, let's mark the produced deflection because of this UDL is del downward. So, in the structure analysis 1 or the strength of materials, we would have seen that the deflection of a cantilever beam when it is subjected to throughout the span UDL, the deflection is nothing but WL power 4 divided by 8 EI. Okay, so now we are calculated the downward deflection. Let's calculate the upward deflection. Go to the procedure step 2. So, in step 2, what we are going to do? Step 2. In step 2, we are going to remove the load and considering only the prop reaction. So, let's remove the load and consider only the prop reaction and calculate the upward deflection. Calculate the upward deflection. So, once again I am going to draw the beam. This time I am considering only the prop support which is going to produce the reaction force P. This is support A and support B and our span L. Now you see, go to the previous slide. Here load is there and then support is there. In step 1 we are not consider the prop reaction, we consider only the load. In step 2 what we are doing? We are not considering the load and we are considering only the prop reaction. So, remove the load and consider only the prop reaction and then calculate the upward deflection. One might ask, beam always deflect in downward direction. How the upward deflection is possible? So, in reality also in many structure upward deflection is not possible. This is for a theoretical purpose. Okay. So, now you see this is almost similar. This is almost similar to this case. The cantilever beam subjected to point load at the free end. If you invert this beam, reverse this beam and see, this is nothing but the cantilever beam subjected to point load at the free end. So, instead of the point load, we are having the support here. That support is going to transfer the reaction force P. Okay. Let's mark the upward deflection. So it is going to deflect in a upward direction like this, and this is called as a del upward. So del upward is nothing but PL cube divided by 3EI. So actually the formula for the deflection of a cantilever beam subjected to point load at the free end is nothing but WL cube divided by 3EI. Instead of W, we are having the P here. So P is a prop reaction, and deflection due to that prop reaction is PL cube divided by 3EI. Okay, so far we have calculated the downward deflection due to the UDL and then upward deflection due to the prop reaction. Let's go to the step 3. So in step 3, we are going to equate del upward deflection and then del downward deflection, del upward deflection and del downward deflection. Let's equate. The upward deflection is PL cube divided by 3EI, and then downward deflection is WL power 4 divided by 8EI. In the examination, in order to confuse you, they are going to give you the value of E and I. They might give you in different units also. You are going to convert that unit and substituting value. Please don't do that, because anyhow EI will be cancelled while calculating the prop reaction. Afterwards, nowhere we are going to use that EI value also. There is a more possibility you can commit mistakes in converting the units. So here we no need to substitute the value even. Okay, so don't substitute the EI value. So first of all, what I can observe here, I can able to cancel the EI values, right? So we will be having PL cube divided by 3 equal to WL power 4 divided by H. Okay, yes. Now in this equation, what I want? In this equation, what I want P. So P is equal to WL power 4 by 8 and then multiplied by 3 divided by L cube. 3 divided by L cube. Okay, so let's cancel this. We'll be having L alone. So P is equal to 3 WL by 8. P is equal to 3 WL by 8. So this is the prop reaction. 3 WL by 8 is a prop reaction we are calculated. So in this lecture, what are the things we have seen? We have seen the procedure to calculate the prop reaction, and also we have seen why propped cantilever is statically indeterminate. Okay, so we have seen degree of static indeterminacy also in this beam. Okay, so in next lecture, the fourth lecture, we are going to discuss some more numerical problems in property cantilever beam, how to draw the shear force and bending moment diagram after calculating the prop reaction. Okay, so thanks for watching this lecture. Thank you.